Lesson 111 starts on page 517 and it's about estimating area. Now if you had some strange shape like that would be difficult to figure out the area, because we think of area like these square boxes. How many of these square boxes can we fit inside that area? So what you might do to figure out the area of that is place it on a grid, and I'm just drawing an example here. Mine's not going to be a real accurate grid, and this is like graph paper basically. And what you could do is count up all of the boxes that are inside that area, and you could estimate the area. And so let's put a dot in each box for this shape that we have here. 1, 2, 3, 4, 5, 6, and then this is almost a whole one here, 7, and then maybe all those other little parts would add up to one whole box, so maybe 8. And so we could say that that is 8 square. We don't have any units like for length on this, so let's just say 8 square units. That would be estimating the area for that particular shape that we just did there. And I didn't say this, but we would also talk about this little piece, this one, this one down here, and this one right there as well when we were estimating our area. Now that's not an exact number, that's why we call it an estimate. An estimate is an idea of the area for that particular area that you're doing. Something to consider here: the smaller the boxes we use, the more accurate we can be, because littler boxes will fit. They will fit into a regularly shaped object or an irregularly shaped object a little bit better. And we can get a little more accurate result if we use smaller boxes, and then we could even use smaller ones than that to get an even more accurate picture. But you've just got more boxes to count up. However, it is more accurate. I mean, that looks pretty messy there, but that should give you the idea anyway. The smaller the boxes that you're counting up, the more accurate you can be on measuring and estimating the area for a particular object. So look at practice problem A. What I want you to do there is estimate the area enclosed by that pattern there. So see that white bordered pattern that I have there? Let's just count up the boxes, and first let's count up the whole boxes, and let's put a red dot in the middle so that we know that we counted them. There's 4, 5, 6, 7, 8. We'll count that one as a whole one there. 9, 10, 11, 12, 13. We'll count that one as a whole one. 14, 15, 16, 17, 18, 19. Now, these two we could count as one whole one. They're like two halves. So let's just write some numbers down over here. 19, and then plus 1 for this and this. We'll count that as 1. This, and this, we'll count that as 1 as well. And then this one and this one over here on the right that I just marked, we'll count those two as 1. So we're doing 19 plus 3. That's equal to 22. And so we'll say that the area is 22 SQ for square units. We don't have like centimeters or inches that we're calling this right now. We'll just say 22 square units. And that would be the estimate for the area of that object. Next, what I want you to do is estimate the area of a tiled surface in your house. Usually the tiles are square in shape. And so you can just count up all the different tiles, and that can be, you could say, well, there's 24 square units. That's the area of my kitchen or my bathroom or some tiled surface in your house. And what else you could do is you could figure out what the area of one individual tile is. And so let's say you had 24 tiles, that was your estimate, and maybe each one of those is 1 square foot, so that would be 24 square feet of surface. So why don't you go do that now? Estimate the area of a tiled surface in your house, and then you'll be done with lesson 111.